In this section, you're learning about logarithmic functions, and the first example is to sketch the graph of a logarithmic function. Now, I hope you must have read this before. Exponents and logs are inverses of each other. So technically, the inverse of this logarithmic function must have been the corresponding exponential function. Now, since we already know the three key points for this, one of the point is going to be 0, 1, then negative 1, 1 over 3, and 1, 3. We already know for this particular logarithmic function, the three key points has to be 1, 0, 1/3, negative 1, and 3, 1. Because they are inverses of each other, the domain and the range switches. Okay. If you have any questions, please read through the book and ask if you need help. Okay, so this is one way of doing it. So if you want to graph this, I can technically put these 3 points and kind of graph the function. But let me show in the graphing calculator too, so you will know how to compare. Like approximately 1, 0 will be here. 1/3, negative 1 will be a point over there. So this should be a 1/3, negative 1. And 3, 1 will be a point there. So I'm saying without even touching my graphing calculator that the graph of this function has to be something like this. And this is what f of x, that function is f of x is equal to log to the base 3 of x. This is my x-axis and that's my y-axis. Okay, so let me use my calculator to just show you that that's what the graph is going to be. So I'm going to hit log. Now since I have a log to the base 3, if you do not have this calculator, then you will have to use a change of base log to graph this function. So change of base log can be used, and this could be written as f of x equals log x over log 3, or you can also write it as ln x over ln 3. I have to use log or ln to use my calculator. So this is one way of doing it. Now since I have this fancy calculator, I have my log with the base. So to do that, I hit math and I keep coming down and I see log base, enter, and this will help me to enter the base 3 and the argument x there. So now I'm going to hit graph, keeping the same viewing window, negative 10, 10, scale 1, negative 10, 10. And I hope you know the meaning of this. The meaning is that my x is minimum is negative 10, maximum is 10. Y minimum is negative 10, Y max is 10. And my scales are going by 1. So this is read as 1, 2, 3 like that. Okay. So if I hit graph, I have the same graph. Now you can cross, it looks like it is touching here, but it's not. If I go back into my table, I would see that, after it gets so closer that it looks like there is an error here. That is the asymptotic behavior of the graph. So, but if you look on the positive side, it's increasing. Okay, so it's getting closer and closer to the y-axis down here, but it's never crossing the y-axis. It's very tiny number. The x becomes very small and small. Okay. Now, if I didn't have this graphing calculator, then the way I can graph this is by inputting log x parentheses divided by log 3 close parentheses. So this is another way of graphing the same function. Or I could have done ln x over ln 3. And if that's the case, I would just use ln x divided by ln 3. Again, I'm able to do all this because of something called the change of base formula. And the change of base formula says that if I have a logarithmic function, let me call the base as a and the variable as say b, here argument as b, then the change of base formula says that I can rewrite this as log to the base anything b, as long as I keep the log on the two over here, the log base here and base here the same, I can write the argument will become the argument of the top and the base will become the argument of the bottom. So this is what change of base formula is. So if you have a calculator that cannot support the base, then you will have to use the change of base formula to graph these functions, or even to find the value of this function. Like for example, if it's asking evaluate log base 3 of 2. So in this case, I can use my change of base formula to find what the value of it is.